Good afternoon, everybody. My name is Colin Gibbons. I'm Director of Product Management at Splunk. I work in our security business unit, and today we're here to talk about an announcement that you might have heard today at the keynote, that we also made an announcement this week at Splunk Conf. With me I have Javier.
Hey folks, my name is Javier Teitelbaum. I'm a Builder Solutions Architect here at AWS. I also support the Customer Incident Response team.
Yeah, so, one of the things that, before I hand it over to Javier to kick off, just to kind of kick off a little bit, Splunk has been working with Amazon for quite some time on a few initiatives. One of the initiatives was with Amazon Security Lake. When Splunk started working with Amazon around the Amazon Security Lake initiative, one of the things that we started talking to AWS about is a schema that Splunk was working on called OCSF that you might have heard about. It's an open standard schema that right now we have over 160 different people, companies, and individuals, everybody that has been contributing to the OCSF schema. Well, AWS adopted the schema, and they're using this schema as part of Security Lake, which Javier will talk about. Well, that was just kind of part one of the partnership between Splunk and Security Lake. The other part of the partnership was, well, a lot of our customers, Splunk customers, will pull data from Amazon into Splunk, which we'll get into a discussion about here. But they also wanted a better way to integrate between Splunk and Security Lake. So that's kind of the things that we're going to be talking about. But just to kind of kick it off, to kind of level set before I start discussing the integration, Javier is going to kind of talk about the building blocks of what we built upon.
Yep, thank you, Colin. So, before anything, our forward-looking statement.
Yeah, so, again, what we're talking about was announced today, so it's not a roadmap item, but anything we talk about from a roadmap point of view is always, subject to change.
Yep, so, to get us all on the same page, Amazon Security Lake is a purpose-built data lake solution. The purpose of it is to centralize and manage data across AWS environments, on-premise sources, and partner solutions. What we're aiming to do is we're aiming to make it easily accessible in a consistent format. In front of us, we have a couple sources with AWS services. Security Lake is not limited to just these services. So VPC, CloudTrail, Lambda, recently announced WAF logs are some of the services that Security Lake ingests. So, sorry about that. So taking it further, so under the hood, Security Lake is simply just an orchestration of S3 buckets, glue crawlers and tables, and custom Lambda functions to create a write once, read many functionality. This write once, read many functionality is going to enable services within Amazon alongside other services and partner solutions such as Splunk to be able to take action on that data. So Colin already talked about OCSF, so I'm not going to spend too much time there. But OCSF is really the glue that's putting this all together, enabling the partner functionality and the additional services and tools to be able to take action on the data centrally stored and managed within Security Lake. So taking it a step further, the difference between Splunk and Security Lake. So Splunk, like many themes, is considered a multi-function tool. Some of the capabilities that the theme has, as well as Splunk, data storage, out-of-the-box rule engines, a front end for incident response, graphical dashboarding and reporting, and graphical attack analyses. These functionalities are supported by data that's centrally stored in a place like Security Lake. with Security Lake, it can be used as a SIEM. It's not really designed to be used as a SIEM. Security Lake works very well with services like Splunk to provide that central store. And tying it back to OCSF, because it's in a common schema that enables a collective standard, it makes it a lot easier and a lot more seamless for individuals conducting an investigation or a threat hunting activity to easily put these services together to be able to create some kind of actionable insight. Taking it one step further to better illustrate the differences in the use cases between the two tools. Yes, Splunk can store data, and yes, Amazon Security Lake can serve as a SIEM, but they best serve in their own capabilities, right? Amazon Security Lake is working best as a central data store for data management. It's in that consistent format that other tools and services are using through the OCSF partnership, that they're able to easily ingest that data. They don't have to reformat. They don't have to recreate glue crawlers or glue tables. That's all done under the hood with Amazon Security Lake. With Splunk, one is able to simply use Splunk to create reports and dashboards and to create visualizations and index data that's stored centrally in the Security Lake for actionable insight. Colin?
Yes, so as Javier was pointing out, when we think about Splunk, the power of Splunk, data aggregation, Splunk, as your Splunk customer, you can basically send any log information you want to Splunk. That was the power of Splunk. Basically a garbage collector of information. Any log format, normalized, not schematized, not schematized, unstructured, not structured. Any data you can send to Splunk, store it in Splunk, and be able to search it, at a very rapid time. And for security use cases, that's very important, because if I'm working in a SOC, I'm a SOC analyst, and I'm trying to sit there and basically determine whether or not my environment has been compromised, I need to have this answer in seconds. I need to be able to go through, look at my logs, analyze my data, be able to have an answer within seconds. Especially today, when you look at the SEC and the regulations with the SEC around how quickly an organization, 2 days, to basically report a breach. So that was the power of Splunk. So with Amazon, a lot of our customers traditionally were using what we call a TA, a technical add-on, which if you're a Splunk customer, everybody is familiar with TAs. You go to Splunk Base, you download a TA to basically integrate with your products. So people were out downloading the TAs, integrating it with the AWS to pull the data from AWS down into Splunk. But what we found was that a lot of our customers were really only pulling a subset of the AWS data into Splunk. Typically, when I talk to customers, it was really CloudTrail. I would say that 90%, 100% of customers I talked to, it was CloudTrail data. After CloudTrail, it was CloudWatch. After that, maybe not so many. Very few customers I talked to were sending things in like VPC flow logs or WAF logs or those types of logs into Splunk. They were either storing them in S3 or they were storing them someplace else, but they wanted to have visibility in these logs. They wanted to have access to these logs for when they needed to go in and do an investigation, or they needed to go in and report on something, that they had access to those logs. But now I've got some logs sitting in Splunk that I'm able to run my detections against or contents against or search. But now if I want to go look at my VPC flow logs or my WAF logs or other things, then I'm having to go use Athena or OpenSearch or something else to go pivot into yet another console to do it. So customers have been asking Splunk, hey, can you help bridge this gap between Splunk and Amazon. So last year we did announce Federated Search for S3, which does allow you to, from within Splunk, search an S3 bucket. You don't need to leave the Splunk console. And so what we announced today here at Reinforce and at Conf was a new integration that we're calling Federated Analytics. And Federated Analytics is something that we announced, and it's going to be there's two aspects of it. And so before we get into the aspects of the Federated Search and Federated Analytics, I want to talk more about kind of the use cases. So, when we talk about use cases within the data from Security Lake, what we found was when we came in here and we talked to customers about reporting, threat detection, threat hunting, all these different use cases, what we found was that customers are like, okay, well, if I need to store data for a long period of time, where does it make more sense to store that data? Well, it makes more sense to store that data in something like Security Lake. Most Splunk customers, typically if you're a Splunk Cloud customer, you're storing data for like 90 days. If you're an on-prem customer and you can afford it, you might throw more hardware at it, more resources at it to store data for a long period of time. But for compliance reasons, for PCI, HIPAA, FISMA, GLBA, et cetera, when you have to store data for long periods of time, then you have to basically look at other options to store that data. Well, great. Now I can look at other options like, other data lakes or blob storages or Glacier or something like that. Well, part of the integration that we worked with AWS was to build this integration between Splunk and Security Lake to basically say, hey, look, if you have to meet your compliance requirements and you want to store your data in Security Lake for long periods of time, great. We're still going to give you access to that data in Splunk. We're still going to be able to give you the ability to go in there and search that data, run queries against that data, or run detections, against that data. When we talk about things like reporting, regardless of whether or not I'm ingesting the data in Splunk and storing the data in Splunk, or whether or not I'm keeping the data in Security Lake, and I want to still be able to create dashboards within Splunk and run queries, SPL queries, against that data to create my whatever, executive level dashboards or whatever dashboards I want to, I can still basically be able to do that. One common thing that always comes up when I'm talking to customers, especially around like VPC flow logs and WAF logs, is usually the thing around threat hunting and retrospective investigation. I found something, an incident occurred. Now I kind of want to go back and look at maybe the network communication between within my infrastructure or between this EC2 instance. We were just talking a little while ago about one of the groups that he works with that does incident response. Hey, a customer's got an EC2 instance that's open to the internet. That's basically command and control traffic that I need to go investigate. Well, I want to go look at my networking data. Well, I might not have that information in Splunk. I might have that data now stored in Security Lake, but now from within Splunk, I can still utilize enterprise security and I can still utilize my correlation rules to basically be able to go in there. So whether or not your use case is around threat detection, basically you're a Splunk customer using enterprise security, you have content that you want to be able to run against that data, even though the data is not stored in Splunk, but I want to be able to run detections against it, or the threat hunting use case of where I want to be able to go ad hoc searching and be able to search the data in Security Lake without the data having to persist in Splunk. So one of the things that we did was we, out of the box, we have a bunch of enterprise security detections that we have shipped with out of the box to basically help organizations be able to use this content as soon as you start taking advantage of the federated analytics. So basically, and let me back up here a few slides and kind of go over something. Oh, somebody messed up my slides, but one of my slides is missing. So there's two different, like I mentioned, there's two different aspects. There's what we call federated search, which is basically from within the Splunk console. I'm able to run a search from within Splunk, and I can search the data in Security Lake without having to pull that data back into Splunk and persist the data. So if you're an on-prem customer or you're a cloud customer, having to pull back the AWS data into Splunk, I don't have to do that if I want to search it. I can do it from within Splunk. Federated analytics is the ability to pull data back from Security Lake and be able to run detections against that data without having to persist that data either. So, for example, if I'm a customer who wants to gain access, I've got a CloudTrail, right here. I've got a bunch of out-of-box detections here that are mostly centered around CloudTrail. So let's say today I'm pulling in the CloudTrail data into Splunk, or I'm pulling in CloudWatch data. But going forward, I'm just going to say, hey, I'm just going to store everything in Security Lake, but I still want to be able to run my detections against it. So now, how it works is within Splunk, you go in, you create a provider, and tomorrow we have a deep dive session where I'm going to be talking a little more about this in detail. But you create a subscriber. That subscriber then listens. And then as the data is coming into Security Lake, you're basically saying, hey, any CloudTrail data, any VPC flow log data, any CloudWatch data, I want to pull that data into this, what we call a temporary index. So in Splunk, whenever you send data into Splunk, data gets stored in what we call an index. So think of this as a temporary index. It's not persistent to disk. It is a rolling window of information that is in memory that you can then put the stuff in this rolling window, and you can get very specific. So if I want to say I want to pull in CloudTrail data, but I only want to pull in this specific category of data, or I want to pull in this particular event class, it's all based on the OCSF schema. So you can get very granular about what type of, for example, CloudTrail data you want to pull in. And then from there, you can persist this data. You can just roll the data into this 30-day rolling window. And then as 30 days comes up, it basically just ages out of the rolling window. But as this data is in this index, it looks just like any other Splunk index. So from your Splunk UI, just how you run your SPL queries today, you're able to go in there and you're able basically to run your SPL queries against that index just like it's any other Splunk index. So when I'm writing my SPL query and I say index equals, whatever, VPC flow log, and then I can basically just go write my SPL query. Or if I have my ES detections that I'm going to run against that index, I'm just basically pointing my detections against that index. So again, the key thing here is that we're giving you two options. The kind of ad hoc threat hunting retrospective use case where data is in Security Lake. There's something I'm looking for, 10.0.0.1, go search it, the data stays there. I go run a search against the data in Security Lake. It comes back with a result telling me whether or not there's a match or not. But that's kind of more your ad hoc searching. And or I want to pull back a series of data into this rolling window where I want to run my enterprise security detections against that data for that more threat detection use case of that kind of more scheduled on real-time querying of data. So we made the announcement today. If you want to learn more, I'm in we have a Splunk meeting room back there, MR10. If you want to come and you want to learn more about this, and I can go in to sit down with you, I can give you a demo of it. I can get into more kind of the nitty gritty details of it, and I can talk to you about the release schedule and stuff like that. We did not GA. We did not. It's not released yet. We just basically made the announcement. Time is up. I'll step off to the side. Basically, if you have any questions. But thank you very much. Again, I'm in room MR10. If you want to come by and have any questions, thank you very much.